Okay. Alright, this is Tuesday. Week 1, day 1. We're using a generic login. And this is scaling networks. Program review, TAI events, academic IT area. So we talked about some adjustments, course overview, pretest. A little review in terms of learning. We think you should be knowledge driven, even though some people are grade driven, task driven. Those aren't bad, okay? But your goal should be to learn the material, which involves working hard to understand. Okay, networks. Can they scale? It's like the whole course is talking about that. Are they reliable? Efficient? The students were giving secure performance. Just because they perform well doesn't necessarily mean they're reliable. Okay? Should be able to grow and shrink. Okay. You always have to be secure. Take a look at some of the other things we talked about. In the course, here we talked about a PC connecting in terms of switches, spanning tree protocol allows us to do this. We can connect switches like this, and spanning tree would stop the problem of a loop, you know, something going and being in here forever. Okay. PC, talking about, you know, the local connection and then some WAN connection. I use Walmart a lot of times as an example. Here I talked about Walmart in Arkansas. They have 3 locations they have connected. They have fiber between them, and then they had little towers, and they would send the signal through the air as a backup, just in case something happened to the other connections. The example in Nyack here at the main campus, OSPF. So we're going to talk about redundancy within switches. We also talk about ether channel, being able to bundle these groups together to get more performance. And we're going to talk about OSPF and EIGRP in a WAN scenario here, where you would pay a service provider to make your connection, and you would run some type of routing protocol to manage all your sites. Here we just talked about data service. These big data centers in which you can pay data service on, for example. Canvas actually uses AWS plus maybe some others, I don't know. Okay, Thursday, scaling. So we're still in week 1, day 2. Anything else in the course? Lab, LAN design, and we talk about remote access. So we assign these addresses. these particular VLANs. We talked about quality of service. We reviewed briefly accessing equipment remotely. This was the layout. Okay, each student set up their VLANs here with these connections in between. So we started with router 15, multi-layered switch 25, and layer 2 switch 1, and we talked about adding an access list later on. So I re-emphasize the idea of you have this border, and here we have all of the end devices connecting in, and then internally we have our distribution, the core, which connects these, let's say, different locations, the distribution that distributes the within the LAN, and then we have access someplace people can connect in. Alright, so that was the lab we set up. Some more items that we talked about. Need to scale, hierarchical design model, talked about redundancy, failure domains, bandwidth, and the access layer. For example, this is not a good layout because if any of these routers fail in the sequence, everything on this side loses access going out and to these other networks. So we're going to change that design probably in the third week, make it more hierarchical. So we have a router and we have this scenario. Alright, and then run that router up. Okay, half done. We talked through this again. We talked about having some app up here, connect into the application layer, present the data, set up the session, figure out how we're going to transport the data. Network, we find the best path, we do IP addressing, we talk about logical addressing, IP4, IP6, data link, MAC addressing, call that physical address, stays with the device, how the bits, we put the bits on the medium. What do we use? Center cross wire, in the air, or cross fiber. Remote access to equipment, putty in and use one of the Linux boxes as a proxy, telnet to here, and then we can get to your equipment. Devices, platform, port density, forwarding rate, power over Ethernet, and we talked a little bit about routers. So now we're in week 2, day 3. Scaling. Talk about reading announcements. We reviewed last week. Talked about the lab and went through some materials LAN design. Okay. Not sure what we did about film, if there's what we're going to look at. VLANs. Set up the WAN part to our network. And the students then distributed the addresses between the devices. And in last visiting with the students, we had connectivity. Oops, let's do that over. We had connectivity all the way out. Thursday, almost done. Week 2, day 4. VLAN trunking protocol, VTP, we talked about that. Dynamic trunking protocol, we talked just a little bit about that. Then actually what we did was we worked more on the lab. We talked about VTP, setting up client server, and then we can distribute VLAN information. Talked about having multiple clients, and then we talked about you can have a client and you can have a switch that's transparent. It can have its own VLANs, but it will send that VLAN information to this client. So when you update here, this client will get the update, but it'll be skipped here. I mentioned adding another server, and so you can adjust this one or this one, and the clients would get the information. Now, how do you manage this layout in terms of having another layout that's separate? It's not affected, so you can create a domain. I just made up this name. You can secure the domain with passwords, so when somebody adds a switch to this domain, it would have to have the correct password in order to communicate. And then we also talked about dynamic trunking protocol, which is different, that talks about how you set up these trunks so that you can connect a switch and have the trunk automatically set up in terms of sharing VLAN information. That was it. This slide was for the programming class to see where we met in the STEM Center. Alright, 2 weeks under our belt. We're going to get into scaling VLANs coming up.